Hello guys, in this video we're going to do a little review on trigs. We're first going to start with angles, trig functions, and unit circle. So let's start with angles first. So angles is the space that is formed between two straight lines. Right? For example, I have line A and line B, and these two lines or line segments, they form the space in here, which we're gonna call this part theta, right? And then we can say that theta is the angle formed by A and B. Okay. So since many of you have taken some sort of geometry or trig class before, I'm gonna go by over this real fast. So two types of angle. We have acute angle, right, which is angle with measures less than 90 degrees, right? And then we have obtuse angle, which are angles with measure more than 90 degrees, okay? So 90 degrees is what we called a right angle, right? And then we note it by drawing a little square here. That's a right angle, has measure of 90 degrees. Right? And a acute angle would be something like this, right? Where the measure of the angle is less than 90. And obtuse angle will be something like that, where the measure of the angle is more than 90 degrees. All right, now that was a quick introduction to some angles, and there are other videos posted on Blackboard. You can check those out, and they have some more information on angles. But for now, I want to move on to trig functions, which is what we'll be focusing on a lot. Okay, so for trig functions, there are total basic 6 trig functions, but today we're going to start with 3 first. Sine theta, cosine theta, tangent theta. And they're read as the following. Okay, like that, sine theta, cosine theta, and tangent theta. And what trig functions really does is it gives or give ratio of two sides of a right triangle. Okay, and let's look at some introduction to right triangle. Let's say we have something like this. Okay, so here we have a right triangle, and let me note that this angle is the right angle. Okay, and by looking at right triangle, we also need a reference angle. Let's say this angle right here is our reference angle, theta. Now, by looking at this theta, we are able to name the three sides of a right triangle. Now, for example, we look at the side that is opposite to the angle theta, which is right here. So we would call this opposite side. Opposite side. Okay. And then the other side that is attached to the reference angle theta and the right angle, that would be called the adjacent side. Okay. And last but not least, the side that is opposite of the right angle is called the hypotenuse. Okay, so hypotenuse also means the longest side, right? It also means the longest side. Okay, so now that we have established the names of the three sides of a right triangle, we are able to define what the trig functions are sine, cosine, and theta, right? So sine theta gives you the ratio of opposite and hypotenuse, right? So sine theta is equal to the length of opposite side over the length of hypotenuse. And cosine gives you the ratio of adjacent side over hypotenuse. And tangent gives you the side that is opposite over adjacent. Okay. Now, many of you might know this a way to memorize this as SOHCAHTOA, like that, right? So the first three letters of SO, SOH, means sine is opposite over hypotenuse. And then the second part, CAH, C-A-H, is cosine is equal to adjacent over hypotenuse. And last but not least, the TOA part, TOA, means tangent is opposite over adjacent, right? So that corresponds to what we have defined here for sine, cosine, and theta. Right. Now let's look at a quick example. Let's say I have a right triangle like that. Okay. And let's say the sides are 3, 4, and 5. And let's say our reference angle is right here. Okay. Now, the first things we have to do is identify which side is which. Right. So the longer side, usually the easier part is to start with the longer side, which is the side that is opposite of the right angle. In this case, it's 5. Right. So that's the hypotenuse. Right? And then the side that is opposite of our reference angle theta is going to be 3. That means that's going to be the opposite side. And 4, that's connecting the right angle and the reference angle. That will be our adjacent side. Okay, so our goal is to find out what sine theta is, cosine theta, and tangent theta. Right? And sine, we know is SOHCAHTOA, so O over H, opposite over hypotenuse, which is 3 over 5. Cosine is adjacent over hypotenuse, which is 4 over 5. And tangent is opposite over adjacent, which is 3 over 4. Okay, and that's it. That's it for trig functions, right? Very easy in terms of definition. They just give you the ratio of two sides of a right triangle. All right, now the second set of trig functions are the inverse trig functions. Well, not the inverse, the reciprocal trig functions, right? So we have cosecant of theta, secant of theta, and cotangent of theta. And let me write down how to read them. Okay, so what these three are, they are just basically the reciprocal of sine, cosine, and tangent, right? So cosecant is 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta. Okay, so once you know what sine, cosine, and tangents are, it's very easy for us to find cosecant, secant, and cotangent. All right, you just need to take the reciprocal of it. For example, if I translate our example here from sine, cosine, tangent to cosecant, secant, and cotangent, first, cosecant is 1 over sine, right? So that's 1 over 3/5, which all we need to do is flip the 3 over 5, which gives us 5 over 3. Same thing with secant. It's 1 over cosine, which 1 over 4 over 5. That gives us 5 over 4. And cotangent is 1 over tangent, which is 1 over 3 over 4. And that gives us 4/3. Okay, so very easy. Once you understand sine, cosine, and tangent, namely SOHCAHTOA, right, how to find sine, cosine, and tangent, we just need to take the reciprocal of sine, cosine, and tangent to get cosecant, secant, and cotangent, right? And sometimes it might take people a while to understand which one is which. So here I'm going to give you guys a really like a shortcut to help you understand. So first, let's start with tangent and cotangent, right? They are the only trig functions with t's in them, right? So tangent and cotangent, COT, they are reciprocals of each other. They are a set. Next, cosecant, cosine and secant. Notice that cosine starts with C and ends with S, and secant starts with an S and ends with a C, right? So it's like if you flip C and S, you get S and C, which gives you secant, right? And the last one, when you have sine and you want to find the reciprocal of sine, we notice that cosecant has S in the middle, CSC for cosecant, right? And they are a set. Okay, so it might take you guys a while to memorize the reciprocals, but it's actually not that bad. After a few practices, you will understand what we're doing. Okay. All right. Next, I want to show you guys how to find a reference angle on XY plane. Okay. So the definition of reference angle is the acute angle formed between the terminal side and the x-axis. Okay, and don't worry, I'll talk about what they are in a second. Okay, so let's say I have the xy plane right here, right? And the positive x-axis, this is where 0 degree is. And then now you can rotate, let's say take a segment and rotate it to here, right? And therefore we have formed an angle of theta. Now, in different quadrants, right, we have quadrant 1, 2, 3, and 4. Right, the reference angle is going to be different every time, right? So let's look at the definition. The reference angle is the acute angle formed between the terminal side and the x-axis. So the terminal side is the stopping side from rotating to create the angle, right? So we rotate from the positive x-axis to this part where the pink arrow is pointing, right? So this is where your terminal side is. Okay, and the reference angle is going to be the acute angle formed between the terminal side and the x-axis, right? So in this case, we have to look at the negative axis in order to find the acute angle, and that's called that theta r. Okay? And that's the reference angle. And to find that, we simply take 180 degrees, because from the positive x-axis to the negative x-axis, we have to rotate by 180 degrees, right? So reference angle is equal to 180 degrees, subtract our original angle, theta. Okay, and this will be different for, depends on where your reference angle is in different quadrants, right? So I'm gonna show you all 4 cases. All right, so let's say we have angles in all 4 quadrants, right? So in 1, 2, 3, oops, 3, and 4. Notice that I'm always rotating my angle starting from the positive x-axis, right? Because that's where the 0 degree is, right? And that theta, right? So in quadrant 1, your angle is exactly the same as the reference angle, right? Because it's formed between the terminal side and the positive x-axis. All right, and in quadrant 2, which is the one we saw, right, we simply take reference angle is equal to 180 degrees subtracting theta. Okay. Now in quadrant 3, we have to consider rotating to the negative y-axis, which is oh no, we still can just consider this part, right? 180, because all we want is this part right here. This part is going to be our reference angle, right? So for quadrant 3, its reference angle is going to be theta subtracting 180 degrees to get you the orange part of the angle, right? Because we don't want the top side, we just want this side in order to be acute. All right, and in quadrant 4, we know that a full rotation is 360 degrees, right? So the reference angle that we want is this blue part right here, right? Between the terminal angle and the positive x-axis, right? So the reference angle is going to be 360 degrees minus theta. Okay. All right, and this is crucial for us in the future when we get into calculus and learn using trig functions to figure out the values on a unit circle. All right, so this is just a quick introduction. Make sure you check out the other videos on Blackboard, and I'll see you next time.